Agilent Technologies tracking generator is a built-in option for the N9000 CXA signal analyzer and is used to characterize the behavior of components or subsystems, such as frequency response and insertion loss or gain. This brief video shows how this option provides you with a cost-effective solution for scalar network analysis. The optional tracking generator works from 9 kHz to 3 GHz or 6 GHz, offers the best performance in the industry and the fastest measurement speed. That allows you to benefit from the tracking generator's -50 to 0 dBm amplitude output and a dynamic range up to 110 dB. Plus, for amplifier test, the CXA tracking generator provides a power sweep mode to verify performance, such as gain compression, linearity, and cutoff power level. In the following CXA tracking generator demonstration, we will use a bandpass filter as the device under test to show how to set up connections between the CXA and the DUT, apply normalization to improve measurement accuracy, and perform stimulus response tests to characterize your DUT. To perform the CXA tracking generator demonstrations, your CXA will need option T03, the 3 GHz tracking generator, or option T06, the 6 GHz tracking generator. Alternatively, you can use the CXA Express configuration N9000A EP003 or N9000A EP004. To begin this demonstration, connect the DUT between the RF input and RF output of the analyzer. Next, preset the instrument using the mode preset key. Enter the tracking generator mode by pressing the source hard key. Use the up and down keys to move the selection highlight to the internal tracking generator and select the source from the table. In a transmission measurement, the frequency response error of the test system must first be measured and then eliminated through a procedure called normalization. To begin, measure the frequency response of the test system by configuring the system as desired for the DUT tests. Set the setter frequency to 897.5 MHz and sweep span to 300 MHz. Next, replace the DUT with a through connection. Turn on the RF output. The default amplitude output is -10 dBm. The yellow line on the screen is the frequency response of the test system. Implement normalization under the Trace Detector menu. Store the frequency response curve of the test system to trace 3 to use as the reference. Toggle the Normalize key to On. You will see the results of the normalization with the reference, i.e. the test system response, displayed in purple. Now, remove the through connection and reconnect the DUT. You will see the DUT response displayed on the CXA screen in yellow and in dB relative to the reference line displayed in purple. The next step measures the shape factor of the filter. Setting Trace Average will provide a smoother trace view. To determine the 3 dB bandwidth of the filter, select Marker 1 and rotate the knob to the center of the passband. There is an NdB point shortcut soft key for bandwidth measurements under the Mes Setup hard key. Here, you may enter -3 dB directly, rotate the knob, or press the up or down button to move the horizontal arrows to show -3 dB. Read the bandwidth at -3 dB roll-off. Enter -60 dB to move the horizontal arrows to show -60 dB. Read the bandwidth at -60 dB roll-off. The filter's shape factor can be calculated by the ratio of the 60 dB to 3 dB bandwidths. Now let's measure the rejection range of this bandpass filter. Move marker 1 to the center of the passband and set the delta marker 120 MHz above the center of the passband. Narrow down the resolution bandwidth until the delta value remains constant. The marker readout now displays the rejection range of the filter. In this case, the filter rejection range is around 95 dB. It should be noted that only an instrument that has a dynamic range higher than 100 dB, such as the CXA, will allow you to accurately measure such a high rejection filter. Additionally, if you look at the lower right corner of the screen, you will see the quickness of the CXA tracking generator's sweep speed. Using the CXA to make this measurement took just 50 milliseconds. Using a competitive spectrum analyzer or Agilent's legacy product can take up to 30 seconds. That means the CXA can provide results 600 times faster than alternative options. In this part of our demonstration, we'll illustrate how to determine the filter's passband ripple. To begin, narrow down the span to 50 MHz and set the amplitude scale to 1 dB per division. Use peak search to obtain the peak value readout and press marker delta. Rotate the knob to move the delta marker to the trough of the passband. The delta marker readout now displays the passband ripple of the filter. While this concludes our video demonstrations, we invite you to take a closer look at how valuable the N9000A CXA signal analyzer and tracking generator can be in meeting your measurement requirements by visiting our website at agilent.com/find/CXA.